Now in this video we will going to discuss about the bitwise OR. So it is a vertical bar. So now if the corresponding bit positions in both the operands are 0, then OR operation results in 0. OR operations, otherwise OR operations results in 1. So what does it mean? If both the operands are 0, then it will be 0. If any one of the operators are 1, then the result will be 1. So the bitwise OR operations on 2 bits are shown below. See equivalent expressions. So 0 or 0 is equal to 0. When both the expressions are 0, both the operands will going to have 0, then it will be 0. So 0 or 0 will be equal to 0, 0 or 1 is equal to 1, so 0 vertical bar of 1 will be equal to 1, 1 or 0 is equal to 1, so 1 or 0 is equal to 1, 1 or 1 is equal to 1, 1 or 1 is equal to 1. So first we'll go for the include stdio.h and conio.h. So void clear screen int abc binary representation a is equal to 10. So a is equal to 10 means 0 0 0 0 1 0 1 0, which we have already explained in the previous case. So that is what we have done here. So 10 2 divided by, so because we have for a binary representation 0 and 1, so first you divide this by 2, 2 5s are 10, so the remainder is 0. Again you divide by 2, 2 2s are 4, the remainder is 1. So again you divide by 2, 2 1s are 2, so remainder is 0. So 1 0 1 0, so that is what 1 0 1 0. Since for the 8 bits you are going to have the remaining bits as in 0. So b is equal to 6. So b is equal to 6, what happens? Again 6 divided by 2, 2 3s are 6, the remainder is 0. 2 1s are 2, so the remainder is 1. So 1 1 0, so you can see 1 1 0, the remaining bits are zeros. So c is equal to a or b bitwise OR, which is a bitwise OR, b will be equal to bitwise c is equal to 14 now in this case. So how we apply the condition? If both the zeros are 0, then it will going to be 0. If any one of the operands is 1, then it will going to be 1. So 0 and 0 or 0 is 0, 1 or 1 is 1, 0 or 1 is 1, 1 or 0 is 1. So according to the bitwise OR. So therefore you will going to get 1 1 0 is the answer. So how we are going to explain this? So 0 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 2 plus 1 into 2 to the power of 3. So 0 into 2 to the power of 0 is 1 into 0 is 0 plus 1 into 2 to the power of 1 is 2. So 1 into 2 is 2 plus 1 into 2 to the power of 2, which becomes 4, plus 1 into 2 to the power of 3 is 8, 8 plus 4, which is equal to 12 plus 2, which is equal to 14. Therefore, bit C will be equal to 14. So this is how you will be able to write this. So printf %d, that is bitwise OR, equals %d backslash n, which is a comma b comma c, and get ch function 10 or 6, the output is 14. So get ch functions. So this is how you will be able to explain the bitwise OR. Now we are going to try to solve this by using a program. So to do that, so first we will go for the Turbo C++. Now we will consider the include stdio.h. So here file, we go for the new one. I will type include stdio.h, then include conio.h, then void main, open the brace, then clr, then int a comma b comma c semicolon, then assign the value of a as 10, b is equal to 6, because that is the one which we are finding out for the bitwise operations. C equals a vertical bar A or bitwise or B, then printf percentage D bitwise or percentage D equals percentage D backslash n A comma B comma C, then get ch function, then close the bracket. When you are explaining for the compilers for CLR CR, A is equal to C, B is equal to say A, C is equal to A bitwise R B, so percentage G gets CS, C will be equal to the 14th value. So this is how you will be able to explain by using a program, and how we are able to get it, which we are already explained in theory, and now we have demonstrated by using the program how this function will going to work. Now then we go for the bitwise XOR. So when you are going for the bitwise XOR, so bitwise XOR operation, so include stdio.h. So here bitwise the left shift operator XOR function. So bitwise XOR. So here the XOR operation include stdio.h and conio.h void main. So CLR is here. Then we have A comma B comma C. A is equal to 10. So 10 value. So we have 2 2s are 4. I mean 2 5s are 10, which is 0. The remainder 2 2s are 4. The remainder is 1. 2 1s are 2. 1 0 1 0. So that is what A is equal to 10. 0 0 0 0 1 0 1 0. So then we have B is equal to 6. So 2 3s are 6 0. The remainder 2 1s are 2. The remainder is 1. So 6 will be having 0 0 1 1 0. So C is equal to A caret B, which is equal to C is equal to 12 now. How we are considering that? 0 or 0 or 0. 1 or 1 is 0. Any 1 is 1, then it becomes 1. So 0 or 1 will be equal to 1, and 1 or 0 will be equal to 1. If both are zeros, then it is 0. If both are 1s, then it will going to be 0. So that is the bitwise XOR says. So that is correct. So printf percentage D or percentage XOR bitwise R D, then is equal to percentage D backslash n A comma B comma C. The output will be equal to A 10 bitwise or 6, which will be equal to 12. So how we are going to explain that? 1100. So 0 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 2 plus 1 into 2 to the power of 3. So 1 into 2 to the power of 3 is 8 plus 1 into 2 to the power of 2 is 4. Then all are zeros. Then 4 plus 8, which will going to become 12. So that will be the value of C now. So this is how you will be able to get this operation. Now to do that by using the program, so first we go for the turbo C. Now we are going to explain that. We have already explained the how it will going to function by using the theory. Now we are going to write a simple code for this. So to do that, first we will go for include stdio.h, then include conio.h, then void main, then CLR SCR clear screen, then we have int A comma B comma C, then we are going to assign the value of A is equal to 10, B equals 6, then C equals A bitwise R, bitwise R, that is caret B, then printf percentage D caret again percentage D equals percentage D backslash n, then you type A comma B comma C, then get ch function, and you should be able to get the value as C is equal to 12 now. So we can see A, B, C, A value, B value, C is equal to A bitwise or B. So you will going to get the value as 12. So this is how this bitwise or will going to work in a program. So this is how you will be able to get the bitwise or. So in the next video we will going to discuss about the left shift operator. Thank you.